The key issues that face the power grid that we're trying to address here at Pacific Northwest National Laboratory are fundamentally the fact that the demand for electricity is growing rapidly. It grows with our population, grows with our economy. And keeping electricity affordable as we grow our electric infrastructure is a key issue for our economy.
The Olympic Peninsula Demonstration Project was designed to demonstrate a number of technologies that would help consumers participate in the operation of the power grid in a way that was beneficial to them as well as the power grid. Generally, power grid operations is really focused more on how power is delivered to the consumer and doesn't focus as much traditionally on how the consumer uses that power. This project was really intended to give the consumer an equal share in that role and then give them an opportunity to get some benefit from that share through incentive payments.
We began to focus on what's become known generically as the smart grid. And we started the GridWise initiative here at the laboratory. IBM was one of the founding members of the GridWise Alliance. Our job as a national laboratory is to show what's possible, show what you can do with technology to bring about the maximum benefits from the smart grid that we can obtain. All of a sudden now, the opportunity, the big aha is that, wait a minute, we can begin to work with the people that are causing the load, the buildings and businesses and industries, and begin to influence the instantaneous level of consumption on the part of consumers, and giving them a share of the action, if you will, in the process, and financial reward for doing that. To test this proposition, we recruited 112 homes and engaged their heating cooling systems and their water heaters, and a few homes their dryers as well, and gave them control technology to respond automatically to prices.
So there were a lot of pieces that had to come together, and those pieces were from different vendors. There was a lot of integration challenges that had to be overcome, including some completely novel technology, particularly in the real-time pricing and the grid-friendly behavior that had never been employed before in this kind of an environment.
IBM played a key role in the project in setting up the communication system that sent out these price signals to customers, and also in implementing some of the function of their thermostat that today's thermostat technology could not do. We built it into IBM's network and contributed a lot of thinking to the general design and operation aspects of the project.
In the Olympic Peninsula project, IBM, and in particular IBM's Thomas J. Watson Research Center, served as overall system architects, system integration architects. And we used WebSphere Application Server as the basis for linking together the back end of the Olympic Peninsula project. The National Lab had implemented their real-time market, and we connected to that through an enterprise service bus using WebSphere Application Server.
The benefits of engaging the customers in communicating and responding to prices is that we're able to reduce their peak demand, their maximum demand for electricity by 15% over the course of a year. That 15% translates to a savings of $70 billion worth of infrastructure over the course of the next 20 years. We are also able to reduce loads by up to 50% for periods of several days at a time. And that's a tremendous capability when you run into a real problem with the power grid. So what all this means for the consumer is the opportunity to save something like 10% on their electric bill by collaborating with the power grid and responding to prices. That's a tremendous opportunity for consumers to have some control over their fate in the face of rising electric costs. The keys to making that happen were making it simple to respond, giving them the ability to automate their response, and giving them an incentive or reward for doing so. And the GridWise demonstration project showed exactly that.